This short video is for my students at Sri Chaitanya, Visakhapatnam. Students going to 11, and in the caption I will put the photograph of all the students to whom I am addressing this. So, today in this short video we will solve one question from inductance, and the book is this one. This is the book from where the question is taken. So, it is a very popular book among JEE aspirants. So, this is the question, my dear students. You read the question and then pause the video and try to solve the question yourself, and then you see the discussion. That will be most helpful, as we do in class. We give you questions and then we give you some time to answer the questions, and then we explain it in detail. So, I hope you have attempted this question, you have read this question carefully, and if you see this question, then here we have a square loop of a side length A. As you can see, total length is 4A, wire length. So, side length is A, side length is A like this, side length is A. So, this is the square of side length A, and its inductance is L1. And here you see again we have two sides of the cube. Side length is A, so total length here is 6A, and inductance of this is L2. Arrow marks are there for the direction of current, as you can see, and then they are asking what is the inductance of this one in terms of L1 and L2. Would it be for the arrangement shown in figure C? So, in figure C we want to find inductance of this loop. Now, it is a different loop. This loop has an inductance of L1, this loop has an inductance of L2, and then we want to find inductance of this loop. So, let us first see the relation between L1 and L2. So, inductance of this is L1, meaning that if I amount of current is flowing in this loop like this, and then flux linkage in the loop, if I call it phi 1, this phi 1 flux linkage through loop 1 is equal to I into L1. This is the flux linkage through this loop due to this current. Now, looking at the second loop, you see here current is flowing like this. Here there is no current. So, what we can do here is, we can think this single loop as if it is composed of two loops like this. You see, there is no current in this branch. So, we are not going to violate anything. So, what we will do is, we will say let current is flowing like this, I down, and current is flowing like this, I up, so that net current in this branch is still 0. Net current in this branch is still 0, but with this technique what we have done is that we made it two loops. Now, obviously, each loop has an inductance of L1, self inductance, but now because they are placed near each other, therefore, current in one loop will also contribute to flux in the other loop. So, if we say that they have some mutual inductance, and let that mutual inductance be M here between these two loops, if the mutual inductance is M, then flux linkage through this loop due to its own current will be I is the current, into L1, and then you can see here current in the other loop is also contributing to flux in this loop, and taking the mutual inductance to be M, I can write I L1 minus I M. This is the flux linkage through one of these two loops. Now, you could ask why I made it minus here, and then these are the type of questions that you ask in the class as well. So, minus is because you can see here, when current is flowing in this loop, is creating magnetic field lines which are coming out of the cube. The magnetic field lines are coming out from in to out, and you know that magnetic field lines always make closed loops. So, these lines which are coming out, they will again go in, but some of them will go in through this loop. So, the magnetic field lines of this loop, if I mark them 1, 2, 3, 4 like this, if I call this is 1, 2, 3, 4 is one loop, and then this 2, 3, 5, 6 is another loop. So, you see that this 2, 3, 5, 6, this loop is there. Okay. So, when some current is flowing in this loop, due to this current, some flux is linked with this loop, that flux being I into M. But then I made minus here because you can see that the magnetic field lines due to its own current is in to out, but magnetic field lines due to current in this loop is in to out here, but then they are out to in here. So, they are contributing to magnetic flux with a negative sign, and therefore, I can say that the flux linkage through this 1, 2, 3, 4 loop is I L1 minus I M, and the same is true for the other loop as well, and therefore, a total flux linkage is twice of this one. So, total flux linkage is twice of this one, but that has to be L2 because its inductance is L2 into I, and then we can say that okay, then this L2 is twice of L1 minus M in the bracket. Now, this is only an intermediate stage. We just have found a relation between L1 and L2, and that too in terms of M. Now, coming to this third one, okay, this is what they are asking. What is the inductance of this loop? How much is L3 is what the question is. So, we will follow the same technique here. Although this is one loop, as you can see, we will make it a combination of 3 loops by assuming current to be flowing in these 3 branches, equal amount of current, but then up, down, and then left, right, in, out, so that we are not altering the flow of current in any branch. Current in this branch was 0 and now also it is 0. Current in this branch was 0 and now also it is 0, and the same is true for this one. But now you see we have 3 independent loops. Now, out of these 3, if we consider one of them, and if we try to know what is the flux linkage through this loop, then obviously due to its own current it is L1 into I, but then the other 2 are also contributing, and we have already checked that the contribution from the other loop, the adjacent loop, is coming with a negative sign, and therefore, this will be minus 2m into I. And then we have 3 of them, so total flux linkage will be 3 into 3. So, total flux linkage is this into 3, and that has to be equal to I into L3. So, from this you see what we got, L3 equal to 3 times L1 minus 2m, 3 times L1 minus 2m. is L3, but then we are supposed to express L3 in terms of L1, L2. We are supposed to express L3 in terms of L1, L2. So, that is what we will do. We can replace this 2m here. You can see here, if you see this expression, then this is L2 equal to twice L1 minus twice m. So, this twice m is equal to twice L1 minus L2. So, I will replace it here. So, this is minus 2m, and minus 2m will be minus 2L1 plus L2, and then that is coming out to be L2 minus L1. So, we are getting L3 is equal to 3 times, this is L2 minus L1.